This is video number 5 on the normal distribution and empirical rule. So we have already discussed normal distributions in our previous video, and we mentioned that if a histogram is roughly symmetric and unimodal, we give it its own name, which is a normal distribution. So normal distributions have a few qualities. They are symmetric, they are unimodal, they have no outliers, and they are bell-shaped. So I have given you several different normal distributions on the right side of your paper. Some things that might be normal distributions: standardized tests such as SAT and ACT scores are normally distributed. Height of 9th grade females would be normally distributed. IQs are normally distributed. Shoe sizes normally distributed. There's a lot of data that is normally distributed. And so if we're looking at the area from mean to infinity, for all of these, the area is slap dab in the middle. Or no, excuse me, the mean is in the middle. So the mean is always in the middle of your normal curve. So what would the area be from the mean to infinity? From the mean to infinity, it's 1, excuse me, not 1. It would be 0.5 or 1/2 or 50% of your data if you go to the mean to infinity. Or the mean to a negative infinity would also be 50% of your data. So notice that even though all of these are normally distributed, their spreads are different. So we have some that have smaller standard deviations than other graphs would. And normal distributions are based off means and standard deviations. And so we're going to take a look at a pattern that occurs in normal distributions through this example that you see below. So in this example, I have provided you with scores of 213 students on an exam in college. Zoom this out a little bit. There we go. And so we have how many questions they got right out of 20. So we had 1 student score 1, 15 students get 7 correct. Now we do have a couple here that were cut off on my Word document. So the score of 19 let me not do those backwards. Let's do 17. So a score of 17, we have 7. That's on your paper. A score of 18, there should be 5. A score of 19, there should be 4. And that should account for all 213 students. So some of that was cut off on your graph. So the first question, does this appear to be normally distributed? Yes. Consider the question of how many scores fall within one standard deviation. So what we are going to do is take our mean, which we are given, and we're going to add and subtract the standard deviation. So we're going to take our mean, which is 10.221, and add and subtract the standard deviation. So once we do that, we get an interval from 6.362 to 14.08. So we're going to count how many students scored from a 7 to a 14. Those would be the scores that would be included in that interval, a 7 to a 14. You can't score 6.3 on our test. So go to your table and add all those together. So we're adding 15 plus 16 plus 17 plus 32 plus 17 plus 12 plus 21. So I have already done that, and if I did it correctly, I hope I did, I get 146. So 146 out of the 213 students will score between 1 standard deviation above and 1 standard deviation below your mean. And this ends up giving us 68.54%. Again, if you want to verify this, you can stop and do the video and do it on your calculator. So I want to do the same thing. This time, I want to look at see how many scores will fall within 2 standard deviations. So I'm going to take my mean and add and subtract my standard deviation twice. And so I have calculated that already. When you subtract 2 standard deviations, you get 2.503. 2, when you add 2 standard deviations to your mean, 17.939. So what scores would be in this interval? A score of 3 to 17. So I need to go to my table and I want to add the count of scoring from a 3 to a 17. So I'm adding 5, 7, 12, 13, 8, 4, and 7 to my previous sum of 146, because they're covered in this interval as well. So when I do that, I find that 202 students have scored within 2 standard deviations. So 202 out of 213. And by the way, I've discovered this that I've actually written this in the wrong place. This is part D. This is 2 standard deviations away. So I did the work for 1 standard deviation in part B, and I should have done that under C. So 2 standard deviations away would be from a score of 3 to a score of 17. There are 202 students that scored in that interval. And when I find that percentage, that's giving me 94.84%. So about 95% of the students scored within 2 standard deviations. And so then I'm going to do the same thing with 3 standard deviations. So I'm going to take the mean and add and subtract 3 standard deviations. So when I do that, I see actually my lower value is going to be a negative number, so that's going to include a score of 1. And then it's going to go to a 21.798, which actually, if you think about it, this is covering everyone. Because you can only score from, we only have students score from a 1 to actually a 19. So this is covering all of our students, and so we will find that 100% score within 3 standard deviations. Now, what this is leading us to is called the empirical rule. Sometimes it's referred to as the 68, 95, 99.7 rule. And it is a rule of thumb. It's a phenomenon that happens in a normal distribution. So when we have data that is about normally distributed, about 68% of our data is within 1 standard deviation away. So what that actually means for us is that if negative 1 standard deviation to positive 1 standard deviation, 68%, here's 34%, and here's 34%. 95% of our data is within 2 standard deviations of our mean. So that's going to cover 95% of our data. So if that's 95 and I subtract 68 from that. So I have 95 and I'm going to subtract 68. I'm left with 27. Divide that by 2. That leads me to 13.5% of the data would fall from negative 2 to negative 1 standard deviations. And 13.5% would go from positive 1 to a positive 2 standard deviations. And then about 99.7% of our data falls within 3 standard deviations. So let me figure out how many, or what percent would go between a negative 3 and negative 2, and between a 2 and 3. So I'm going to take 99.7 and subtract 95. That leaves me with 4.7. Divide that by 2. 2.35% and 2.35%. So if we've covered 99.7% of our data, only 0.3% is left on the ends. And those would be unusual if someone fell in that interval. So that means that 0.15% would be below 3 standard deviations and 0.15% would be above 3 standard deviations. I have an example of that fully drawn in and below. So let's look at how we can use this. So we have verbal SAT scores in a particular year had a mean of 490 and a standard deviation of 100. Draw and label your normal curve. So in the middle of this normal curve, we'll go 490. One standard deviation above would be 590. One below would be 390. I'm just adding and subtracting 100. 2 above would be 690. 2 below would be 290. 3 above would be 790. 3 below would be 190. And I'm going to go ahead and label my percentages here, and I'm a little off on drawing this. So between one standard deviation to the left and one to the right is 68% of the data. That means 34% of the data will be between a 390 and a 490, and 34% will be between a 490 and a 590. So from 290 to 690, again, we learned that that's 95% of our data. So between a 290 and 390, that would leave us 13.5%. Between 590 and 690 is 13.5%. So 3 standard deviations away is 99.7. So between 190 and 790, 99.7% of our students score between that. So 190 to 290 is 2.35%. And this is also 2.35%. So what's left over? Well, we have 99.7%, so 0.3% left over, which means 0.15% score better than a 790, 0.15% score below a 190. So we can use that to answer questions. What percent of students scored between a 390 and 590? So go to my curve. Here's 390, here's 590. That's 68% of our students. One student scored a 795, so they're over here on my curve. How did they do compared to the rest of the scores? Well, look where they are. They are in the top 0.15 percentile, meaning they scored better than 99.85% of all other students. They're probably going to go to whatever school they want. A rather exclusive university admits students who were in the highest 16%. What score would they need to qualify for being admitted to the school? So we're looking at the highest percent. So we have 0.15 plus 2.35. So that gives us 2.5. Add to that 13.5. Oops, I think we found our 16th percent. So these kids need to score a 590 or better. So again, this is a rough sketch. An empirical rule, the normal curve, gives us a good way to estimate these things. So I'm actually going to pull up the next problem for you to just check your answer. You can go check your answer on this next problem. So notice I've drawn and labeled my normal curve, and then I've just used my normal curve to answer these questions. So you might want to go work the problem yourself, pause the video, and watch it. Same thing in example 5. You might want to pause the video, do it yourself, and then see if you got it correct. And same thing, it looks like I've been answering some questions there. Same thing on example 6. I'm just going to pull up my solutions and you can go check your work. If you need any help, come see me.